students, so this video here is about proving triangles congruent. Let me just go ahead on and start by saying for my students who are enrolled in my classes at our school, I hope that you had a wonderful break, but again, we're back now. Alright, so again, this video here and this lesson is about proving triangles congruent. We talked briefly in our previous video and lesson about certain things involving congruent triangles. So here, before we get into this video here, we just kind of want to remind you very briefly of those things that were discussed in that last lesson, because we're just going to build on that right now, and we're going to kind of review that and go into more examples with how to prove triangles congruent, because in that last video we didn't actually get into any specific examples with those 5 congruency shortcuts that we discussed. Alright, so let's go ahead on and review, and then we'll pick up from right where we left off. Alrighty. Alright, so folks, 2 triangles are congruent only if all 6 parts, and when we say all 6 parts, we mean the 3 sides of a triangle and the 3 angles of a triangle. So 2 triangles are congruent only if all 6 parts of one triangle are congruent to the 6 corresponding parts of the other triangle. So again, if all 3 sides of one triangle are congruent to the corresponding 3 sides, and if all 3 angles in one of the triangles are congruent to the 3 corresponding angles in the other triangle, all 6 parts. Okay, alright, so if that's true, and those corresponding parts in those different geometric figures are congruent, then hey, we got ourselves 2 congruent triangles. So guys, remember that during that last previous video, the one where the original sound got all the way jacked up, and hopefully this one here isn't messed up like that, and hopefully y'all can literally hear my voice, and I won't have to ask y'all to watch this with no sound. But anyway, so remember in that last previous video that we did an example. It was a very long example because I was explaining out each little part of it, and I was asking you guys, asking us to prove that those 2 triangles were congruent, showing that all 6 parts were congruent to the corresponding parts of the other triangle, and we were only given a certain limited amount of information, and we had to use that information to find information the other information that we didn't know. And so again, folks, that example there that we did in that last previous video, it was not one that was using one of these 5 triangle. Yeah, and why didn't y'all tell me I spelled triangle wrong? It's all good, because I know how to spell. That's all right. I can correct that. Triangle. Triangle. There we go. Alright, so again, that example that we looked at in that previous video was not using one of these 5 triangle congruence theorems. So guys, there are 5 triangle congruence theorems that are used as shortcuts in proving that 2 triangles are congruent. And those shortcuts, and again, they're not really, like, technically they're not really called shortcuts. They're theorems that are used to prove that 2 triangles are congruent. So, but again, they can be used sort of kind of as shortcuts in proving 2 triangles are congruent. All right, so guys, those 5 triangle congruence theorems are SSS. Which again, if you watched our last previous video, you know that the S's there stand for side. So SSS stands for side, and you know that the A's in that, the S stands for sides and the A stands for angle, right? So side, angle, side, as in SAS, side, angle, side, ASA, AAS, and HL. And again, if you watched our last previous video, then you know that the H stands for hypotenuse and the L stands for leg, right? Yeah. All right. But anyway, we're gonna just briefly talk about those 5, and then we're gonna do some examples, and that's really all that I want to do with this, showing you how we can use congruent triangles and how we can use these 5 triangle congruence theorems to prove that 2 triangles are congruent. And we're going to look at a whole lot of examples, or at least at enough examples to make sure that you get a good idea and a pretty good idea of how we use these things and how we do this. Okay, so again, folks, the SSS, or again, and SSS is just short for side, side, side. This congruence theorem states that if 3 sides of one triangle are congruent to the 3 corresponding sides of another triangle, then those 2 triangles must be congruent. So again, if you've got congruency symbols, or even if you had the same side length for all 3 of the sides, like if this one was 30, that one was 30, right? You know what I'm saying? If they didn't have congruency marks, even if they had actual side lengths, like 35, 35, you get what I'm saying? Even if they had side lengths instead of the congruency marks, again, folks, it would still be that these 2 triangles could be proven congruent to each other, so long as we saw and could really prove that all 3 sides from one triangle were congruent to the 3 corresponding sides in the other triangle. If that's true, then we can say that these 2 triangles are congruent by the side congruence theorem. Okay, so again, then you can say that triangle MNP. Okay, if you're looking at this diagram over here, you can say triangle MNP is congruent to triangle QRS by the SSS, or the side theorem. Based on that theorem right there, based on that theorem, you can say that those 2 triangles are congruent, right? Okay, and that should make sense to you. Alright, well, you can say that these 2 triangles are congruent based on that theorem right there. Okay. All right. Okay, so folks, the SAS congruence theorem, which of course stands for side, angle, side, right? Because the S's stand for side, the A stands for angle, right? So side, angle, side, SAS, right? So the side, angle, side congruence theorem pretty much states that if 2 sides and an included angle, so if 2 sides and an included angle of one triangle are congruent to the corresponding sides and included angle of another triangle, then those 2 triangles are congruent. Okay, so if you watched my last video, then you saw, okay, because you couldn't hear me, but you saw me try to explain that or at least you saw the same thing that you're seeing now, but hopefully now you can hear my voice. But anyway, then guys, an included angle is an angle that is between 2 sides. That is not just between 2 sides, but an angle that's between 2 adjacent sides of a polygon. So again, guys, like if you had something like that right there, okay, and if you wanted to identify the included angle between 2 adjacent sides, right? So let's say that we were talking about this side, and let's say that we were talking about this side, right? So these 2 sides of this rectangle, well, we don't know that it's rectangle right now because we don't know that we've got all right angles. You can assume that, but what I tell you to do, I told you not to assume, right? So anyway, we got this four-sided polygon, which we call a quadrilateral, and we got 2 adjacent sides here. The included angle for those 2 adjacent sides, the included angle would be this angle right, yeah, okay, y'all know which one I'm trying trying to point to, would be this one right here. The angle that's literally right between those two sides. The angle that pretty much gets formed by those two sides. Right? So it's the same way. It's the same way in a triangle. Okay? The exact same way in a triangle. If you got yourself two sides that have been identified in a triangle, like this one and this one, and you want to state which one is the included angle, or if you needed to sure enough know which one was the included angle would be this angle right here. Would be that one as the included angle. Okay. Alright, so again, that's that. Moving on. Actually, before we move all the way on, let me make something clear here. In this diagram over here on the left side, the one that's up under here, up under where you see the included angle, like typed out in red, where you see that, these three triangles right here, where I'm putting my little yellow thingy, you should be able to see it, because if I can see it, you can see it, because we're recording the screen. So anyway, yeah. So those three triangles right there are not congruent, by the way. Even though you can see like two sides and an included angle marked. You can see that marked for all three of these triangles. Folks, you don't have the same type of congruency marks. Notice the types of congruency marks that you have for the side lengths. You got one tick mark here and one there, but you got two little tick marks for a congruency mark there, but it doesn't match up with the congruency mark for this side. You get what I'm saying? So the congruency marks doesn't really match up. Even though now the only thing that they're showing you here is that really they're showing you included angles, but really, guys, these triangles right here are not congruent. Okay, I want to make that clear so nobody gets confused about that. These triangles, those three right there. I hate if that looks sloppy, but oh well. Those triangles right there are not congruent by the side angle side theorem. Okay. They are not, absolutely not congruent. But guys, in the other diagram that you're looking at over there, where it shows you those two triangles, triangle PQS and triangle WXY, those two triangles are congruent by the side angle side congruence theorem, because again they show in those two two sides that are literally congruent to the two sides in this other triangle, and they show not only just two sides that are congruent to the corresponding sides in another triangle, but they show an included angle from one triangle that's congruent to the corresponding included angle in the other triangle. So again, these two triangles are congruent by the side angle side theorem. And again, folks, I'm going to show you examples of again different types of ways that we can use these theorems. And that's what the majority of this video is going to be about and going to be showing you. Alright, so these two are congruent by the side angle side theorem. Alright, now moving on. Alright, so again, folks, the angle side angle, or ASA, congruence theorem, pretty much states that if two angles and an included side of one triangle are congruent to the corresponding angles and included side of another triangle, then those two triangles are congruent. So again, folks, when we say an included side, what we're talking about is a side that is between two angles. So as you can see right here, as you can see here, they're showing you what the included sides here look like for these three triangles. Yeah, they're showing you included sides for these three triangles here. Okay, the side that is literally right in between two adjacent vertices. So again, folks, if you got yourself a polygon and you got two adjacent vertices, yeah, I don't even know what diagram I'm even. Yeah, okay. I guess it's a pentagon. It sure didn't look like it at first, did it? Nope, sure didn't. I was wondering what in the world was you drawing? Okay. Anyway, so if you had two adjacent vertices. So again, if we were talking about two adjacent vertices, maybe like this one and like a this one, right? Two adjacent vertices like these two, that one, right? Yeah, and I know that's kind of small. Let me see if I can make that a little bit bigger, y'all. Okay, that's much better. All right, I think you'll be able to see what I'm talking about now. So if we had two adjacent vertices like these two, clearly there's only one side that is in between that's in between those two adjacent vertices. Only one side. Really? Only one side that's in between them. Okay? There's only one side that's in between those two. If you can't see that, folks, I don't really know what to tell you. Now, I'm not talking to those folks who are blind. But again, if you can't see the side that's in between those two adjacent vertices, I don't know what to say to you. I just don't. But this one here would be considered the included side. So again, now, of course, guys, we're talking about in two triangles, but again, the concept of an included side is I'm just showing you here with this pentagon, but again, we're talking about in two triangles. All right, so again, folks, if you got two angles and an included side of one triangle that are congruent to the corresponding angles and included side of another triangle, then those two triangles indeed are congruent. Gotta be congruent to each other. Alright. So again, folks, in the little diagram that you're looking at, right here, on the left side, with these three triangles, guys, these three triangles right here are not congruent to each other. Because, guys, your congruency symbols do not match up for the angles. They do not have matching congruent symbols for the angles there. So again, it might look like angle side angle because they're showing you certain congruency symbols that show angle side and an angle. They're showing two angles and an included side. But guys, these three triangles that they're showing you right here are not congruent to each other, because the congruency marks for the angles in these three triangles do not match up. So again, folks, these triangles right here are not congruent. Are not, definitely, most certainly, indubitably, definitely not congruent. But guys, those two triangles in the diagram that's on the right side there, those two are congruent. Yes, they are indeed. They're showing you two triangles. The congruency symbols for the angles there, they match up, okay? And then they're showing you an included side and they're showing you that those two included sides are also congruent for each triangle. So again, those two triangles there are congruent by the angle side angle congruence theorem. All right, moving on. Okay, folks. So this next theorem, again, that we talked about in the previous video lesson, is the angle side congruence theorem. And again, folks, this theorem, the angle side, AAS, angle side congruence theorem, states that if two angles and a non-included side. Now, folks, clearly, if we know that there is a included side for two adjacent vertices, for two adjacent angles, two adjacent vertices, if we know that there is one included side, guys, out of the three sides that's in the triangle, if there's only one side that's included in between two angles, then you should clearly know that there are two options. There are two options that we should have for non-included sides. Right? If there's only one included side, then it should make sense, folks, that there are two options that we technically have for non-included, as in not included between two angles. Right? Okay, I'm glad y'all see that. Awesome. Okay. All right. Two options for non-included sides. There's only one included side between two adjacent angles, or between two adjacent vertices in a polygon. But there are two options for non-included sides in a triangle. So in a triangle, there are two options for a non-included side. So it's one of the two sides that is not included, that is not between those two adjacent vertices. Okay? Alright, that should make sense. It's just the opposite of it, okay? It's the antonym, okay? The exact opposite of it, the antithesis, okay? Don't make me start using big words. Y'all know what I'm talking about. So again, folks, if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then these two triangles have to be congruent to each other. Okay? So as you can see here, in the diagram that's on the right side here, that diagram that's on the right side here, you can clearly see that they have two angles right there. You see those two angles, okay? And folks, now again, I'm about to mark the included side, right? So I'm about to mark the included side for those two angles. You see that? That's the included side for those two angles, the one that I just marked right here. And so the side that they've got marked is not the included side right there, right? So if the side that I just marked is included, and this one here that they've shown is non-included, right? Then clearly, folks, now I'm about to erase the one that I marked, the one that was included, right? So the one that they've shown on the diagram is clearly not included between those two angles. Alright? So in order for you to understand what, or for you to get what a non-included side is. First, you need to understand what an included side is, right? Okay, I'm glad y'all understand. Wonderful. If not, give me just communicate with me. I get you straight. Okay, my students enrolled in my classes at our school, you know how to contact me if you need some help with understanding it. So feel free to do so. Anyway, moving on. All right, so again, folks, they've got the non-included side there that's also congruent for these two triangles. And so, again, since they've got those two angles and that non-included side, and is congruent to the corresponding parts of the other triangle, then these two triangles here are congruent by the angle side congruence theorem. Okay, I thought it was going to do my little thing. I'm going to have to see if I can still get it to do it. There we go. Look at that. Yeah. All right. Yeah. All right, so again, these two triangles here are congruent by the angle side congruence theorem for triangles. All right, moving on. All right, so folks, this last congruence theorem that we use for proving triangles congruent is the HL congruence theorem, and this one is again, folks, one that stands for hypotenuse leg. Again, folks, remember that the word hypotenuse, that term hypotenuse is specific. It is very specific to right triangles. You will only hear the word hypotenuse used as far as in math. You will only hear that word hypotenuse used when we are talking about right triangles. So this congruence theorem here only works for right triangles. So now, folks, what does that mean? Does that mean that the other theorems that we talked about just above this one, the side angle, and angle side, does that mean that those four other theorems do not work for right triangles? No, that's not what that means. Those other four theorems can also work in right triangles. I'm not saying that those four theorems can't work in right triangles. What I'm saying, folks, is that this theorem, this one right here, the hypotenuse leg congruence theorem, the HL congruence theorem, the one that has that word hypotenuse in it, this theorem only works for right triangles. Because again, that word hypotenuse, that is something that you only see, at least in math, it's something that you only see when we're talking about right triangles, okay? You don't have a hypotenuse in any other type of triangle except for right triangles. Now, does that mean that every right triangle that you'll be able to use the hypotenuse leg congruence theorem for every right triangle? No, of course not. There wouldn't be even a need for the HL congruence theorem if you could just say that every right triangle was congruent by the HL theorem, right? Come on, folks. Anyway, so this one says that if the hypotenuse and the leg of one right triangle are congruent to the corresponding hypotenuse and leg of another right triangle, then those two triangles are congruent. So again, folks, if you have the hypotenuse and it is congruent to the hypotenuse of another triangle, and then if you have the leg and it's congruent to the leg of another right triangle, then folks, and only then can you say that those two triangles are congruent by the HL congruence theorem, or hypotenuse leg congruence theorem. Remember, folks, that whenever you have a right triangle, okay, that's close enough. Remember that when you see that right angle, wherever that right angle is, remember, folks, that when you see that right angle, whatever. I'm trying to draw it out, but it ain't. Yeah. Wherever you see that right angle, whether you see a 90 degrees, like actually written out there, or whether you see that little 90-degree right angle symbol that looks like a box in the corner. Okay, remember that the hypotenuse is always that side. Like if you go directly from that 90-degree angle and draw an arrow, arrow to the opposite side. And what do I mean by opposite side? I mean the side that is literally not right. The side that's literally not right beside that, that 90 degrees. So you can see the two sides that are literally right beside the 90 degrees. We're not talking about those two sides. We're talking about if you draw an arrow directly across from that 90 degrees to the longest side of a right triangle. We're talking about this side right here being your hypotenuse. And I'm going to write hype for short. Okay, because I don't have enough space right here to write hypotenuse, the whole word hypotenuse. Okay, so I'm going to write hype for short. Okay, so again, folks, we're not talking about these two sides that are literally right up on the 90-degree angle. We're talking about the other side that is directly across from your 90 degrees. That is always going to be your hypotenuse in right triangles. Don't forget it. Okay, remember not to forget. Forget to not, okay, remember to not forget. Don't forget to remember. There we go. Okay. So again, we're not talking about these two sides that are right here, that are right there, right beside your 90 degree, but we're talking about the side that is directly across from, that is opposite from that right angle, from that 90 degrees. That one is considered your hypotenuse, the longest side of a right triangle. And the other two, those other two sides that are right beside the 90 degrees, that 90 degree angle, those two sides are considered your legs. Don't forget that, folks. So again, folks, when you have one hypotenuse and a leg from one right triangle that's congruent to the corresponding parts in another triangle, then and only then can you say that those two triangles are congruent by the HL theorem. All right. Hope that makes sense, folks. Cause there ain't no other way ain't no better way I can explain that. Alrighty, we're gonna look at a few examples next. Alright, and that's really gonna be all that this video here is including. So we're gonna look at some examples and just kind of go a little bit deeper into this and make sure that you got a good understanding of all of this. Okay. Alright, so coming up, some examples that we're going to look at. Examples coming right up. Alright, so let's look here at example 1. I said example 1. I said example, okay, you heard me. Alright, so let's say if it says indicate the additional information needed. So in other words, guys, what additional information is needed in order to enable us to apply the specific congruence postulate? So what do they mean? Let's do it one by one, right? So let me just kind of draw like little makeshift diagrams right here over here to the side, and we'll do it one by one, right? Using what we've been given and tell what else we would need to know in order to show that these two triangles were congruent by such and such congruency theorem, right? What additional information would we actually need to know? What specific additional information would we need to know? All right, so let's say that again, based on what we've got here so far, we've got what that angle is congruent to this angle, and this side is congruent to this side, right? So that's the information that we've been given so far. And if we wanted to state that these two triangles were congruent by the angle side angle congruency, right? Then we would need to have two angles, right, and an included side, correct? That's what we would need to have, right? Two angles and an included side. And we don't have that right now, do we? No, we do not have two angles and an included side. So folks, guess what? What additional information, in other words, where does that other angle have to be in order for us to have two angles and an included side? Y'all get what I'm saying? I hope so. There ain't much other way that I can explain it. So what else will we need to know what other type of congruency, what specific congruency will we need to see here in order for us to have two angles and an included side? I hope you know. Okay? Alright, so let me see. Let me go ahead on and mark these angles. Angle A, angle C, angle B. And what were these three? Angle D, angle E, angle F. Oops. All right, so folks, in order for us to be able to have this be congruent by angle side angle, okay. So there's only two angles that we have to choose from, right? So let's see here. I'm gonna ask you guys this: Would it be this angle here? Would this angle here be the angle that gives us angle side angle? Would it be the angle? Would it be this angle that gives us angle side angle? Nope. No, it will not be this angle. Not at all. Because with this angle here, the side is not in between those two angles. Y'all get it? Okay. If you tried to say that it would have to be this angle that would be congruent in those two triangles, then that wouldn't be an included. That wouldn't give us an included side. Y'all get what I'm saying? That would not give us an included side. So again, it would definitely not be those two angles that I have marked in green. It would not be those two angles. But it would be, I say again, I do say now, it would be these two angles right here. So this angle would have to be congruent with that angle. Angle B would have to be congruent to angle D. So again, if angle B was congruent to angle D as well, then we could say that those two triangles are congruent by angle side angle. You get what I'm saying? I hope so, okay? Because if you not get what I'm saying here so far, then my students have my contact information. You can call me if I'm doing a poor job. If in your opinion, if I'm doing a poor job of explaining this here, or if you just not getting what I'm saying right now, and you need a little bit of extra help, that's fine. Again, my students have my contact information. You can contact me. Anyway, if this particular information was also true, and again, folks, you can see what the original diagram looked like here, right here. Don't act like you don't see it. You can see what the original diagram looked like. So if this information here was also true, then and only then could you say that those two triangles were congruent by the angle side angle congruency. And triangle ABC would be congruent to triangle. Oops, okay. I thought it was going to do my little thing, but jiggy there. It's okay. It's all's right. It is all's right. We gonna get it one way or another. One way or another, we gonna get it. There we go. So triangle ABC would have to be congruent to triangle FDE. By the angle side angle congruence theorem. By the ASA angle side angle theorem. Wow, what did that do? Did it really do that with my E? Seriously? That is so annoying. Okay. By the angle side angle congruence theorem. Alright, great, lovely, awesome. Alright, so again that was for this first part here. For the angle side angle. Okay, ASA. The other two parts, if you wanted to show that these two triangles, that the original two triangles that they gave you right there were congruent by the side angle side, then of course, guys, you would need to have two sides and an included angle, right? Okay, this should make sense. Two sides and an included angle, right? If you wanted to use the side angle side congruence theorem. And guys, I'm starting off by explaining this right here because, guys, these three theorems here are the three that in my opinion are the three congruence theorems for triangle congruency that students most commonly or most frequently get mixed up, or the ones that they do or use wrong most frequently. So again, you have to have two sides and an included angle in order to use this one here. Now, right now, folks, based on the original, based on that original diagram that we had, we don't even have two sides marked. Wow, what is that? Get out of here. Alright, so again, folks, we would need to have two sides and an included angle in order to do that there. So let's go ahead on and draw that out. Again, folks, I can just say the answer and be done with it. I don't have to really write all of this out. But seeing as to how this is a tutorial video and I'm trying to explain what we're doing here and make sure that you got a good understanding of it, I'm not just going to say what I'm doing. I'm gonna give you a visual and everything like that too, and we're gonna explain it the right way. Okay? Yeah. All right. Awesome. For those people who may not want me to actually do all of this, great, lovely. That's fine if you don't want that, but I'm gonna do my job, okay? I'm gonna do what I need to do to make sure that everybody has the best chance at understanding what's going on. All right. So again, if we got these triangles here, and again, if we needed to show that these two triangles were congruent using the side angle side congruence theorem, then we would again, hold on, let me put these markings that were already there. So the ones that were already there were this one and this one here. Oops, hold on, wait a minute. This one and this one were already there. All right, so again, if we needed to show that these two triangles were congruent by side angle side, where would you what additional information would you need to know? What specific congruence would you need to know in order to say that these two triangles were congruent using the side angle side or the SAS congruence theorem? So let's see here. There are clearly two sides to choose from, right? Two sides to choose from in order for us to have two sides and an included angle. So here's a question: would it be this side that would have to be congruent to this side? Okay, with these two sides that I've marked in green, with those green congruency marks, would those two sides have to be congruent to each other? And would that be two sides and an included angle? No, right? Of course it wouldn't be this side with this side, right? Come on now, it wouldn't be those two sides, because if it was those two sides, then this angle right here wouldn't be an included angle. It wouldn't be the angle that's in between those two adjacent sides, right? So again, it would definitely not be these sides that I'm erasing right now, okay? But it would have to be this side being congruent with this one. Now, folks, if it was these two right there, then and only then would we be able to say that these two triangles, that these two triangles were congruent by the side angle side congruence theorem. You know what I'm saying? You know what I mean, y'all? You know what I mean? Y'all know what I'm saying. You know, shoot. Act like y'all don't understand what I'm saying. You know? Anyway, so if it were these two sides here that were congruent, so if this side, whoa, what is it doing to my C? There we go. If these two sides right here were congruent, if side AC was congruent to side FE, then and only then, so if this additional information was needed, again, so if we also knew that these two sides were congruent as well, then and only then would we be able to say that those two triangles that they've got right here, the original two triangles that were shown right there, you see them, that those two triangles there were congruent by the side angle side congruence theorem. Triangle ABC is congruent to triangle FDE by the side angle side congruence theorem. Ooh, that's sloppy. Okay, y'all gonna have to excuse the sloppiness, but it's gonna have to do for right now. FDE, that's a D, guys, not an O or anything like that. That is a D. FDE. Alright. And those two triangles would be congruent by the side angle side theorem, SAS. Alright. Okay, and then the third one that they're asking us to look at here is, okay, I thought it was going to do my little thingamajiggy, my little thingamajigger-bobber, but it didn't do my little thingamajigger-bobber. There we go. It did my little thingamajigger-bobber. All right. Don't ask me what a thingamajigger-bobber is, because I don't know what a thingamajigger-bobber is. But it's okay. It did my thingamajigger-bobber, so that's all that matters. All right. Now, the third thing that they're asking us to do, or they're asking us to again, what additional information would be needed to show that these two triangles were congruent by the angle side congruence theorem. Okay, again, folks, we're going through this to make sure that you really get what these three theorems would look like. Because again, folks, if you don't get what it would look like for it to be an angle side angle, or what it would look like for it to be side angle side, or what it would look like for it to be angle side, then yeah, that's gonna be kind of tough on you to do what we need you to do here. All right, so again, angle side, that's where you got two angles and a non-included side, right? Yeah. Okay. Let me see if I can move that up. Yeah, okay. That'll work. Better. Much better. A little bit better, anyway. Okay. Alrighty. Angle side. Two angles and a non-included side. Okay, that is not an ampersand, but we're going to try that again. And, that looks better. And a non-included side. Ooh, that is not included. There we go, included. And a non-included side. Alright, So again, folks, let me draw out those original two triangles. Let me mark those up. A, B, C. Easy as 1, 2, 3. A, B, C. 1, 2, 3. Yeah, Michael Jackson. Yeah. Candy girl. Alright. Yeah, that's how you know Mr. Starkey is tired. Alrighty. Let's see here. F, D, E. When I start to digress like that, that's how you know. Yep, Mr. Starkey must be tired. Sure enough. Alright, so let's see here. Alright, so and the congruency marks that were already there were this one here, and that one, and this one, and this one right there. Okay. So if we wanted to show that these two triangles were congruent by the angle side, we would need to have two angles and a non-included side, right? So guys, so what would that additional information, what additional congruence would we need to know in order to say that these two were congruent by the angle side? And so there are only two angles for us to choose from, right? Because now we know that we need to have two angles and a non-included side, right? Right now they only have one congruency marked for an angle, right? So we only have two angles that we could choose from here. Y'all feel me? Y'all feels me? You get what I'm saying here? So here's the question: would it be this angle? Would it be this angle that's congruent to this angle? And would knowing that congruency, would that additional information there allow us to say that these two triangles are congruent by angle side, where we have two angles and a side that is not included, a side that is not between those two angles, a side that is not between those two adjacent vertices. So is that what we have here? When I put those two congruency marks there, did we all of a sudden have one side that was not included? I think not. I know not. No, folks. No. Alright. So folks, that one there, that didn't do it. Alright, but what will do it, what will allow us to say that these two triangles are congruent by the angle side theorem, meaning that we'll have two angles and a side that is not included, or a side that is not between those two. Alright, so again guys, if the included side is this one, included, this is the included side. So guys, the one side that I've just marked, that means that if this one is the included side, that means that this side that is marked there with a congruency mark is clearly not included. So that should make sense there, okay? Alrighty. Okay, I'm erasing that. So again, as of right now, we've got ourselves a situation here where we can say that these two triangles are congruent by the angle side congruence theorem. So if we knew that angle A was congruent to angle F as well. So if we had this additional information here, then and only then could we say that those two triangles were congruent by the angle side theorem. Okay, yeah, it did do it. It did it. Triangle ABC, it congruent to triangle FDE. You know what? I don't even want to write out. I don't want to write that out like that. I do not want to write out that congruent statement like that. You know what? We're going to switch it around. We're going to change it. We're going to call it triangle BAC. Yup. Triangle back. Watch that. Yup. Now what? Now what, huh? Now how we going to finish this congruent statement? Huh? Do y'all remember that when we writing out congruent statements that we need to match up our corresponding angles? So which angle is corresponding with angle B? Oh, y'all thought I forgot? Y'all thought I forgot? Oh, y'all thought I wasn't going to emphasize and reiterate what we had talked about? Oh, not going to happen. So which angle corresponds with angle B? Hopefully you guys are saying that angle D is the one that lines up with angle B, right? So angle D would have to come first if we were going to write out this congruency statement, okay? All right, so, and then which angle corresponds with angle A in the other triangle? Well, angle F corresponds with that one. And which angle corresponds with angle C? Well, angle E corresponds with that one. So guys, again, if we switch the order of the way that congruency statement is written, instead of writing triangle ABC, if we wrote triangle BAC, we would also have to switch the order of the other triangle, of the way that the other triangle was written too, so that those corresponding angles were matched up so that they came in the same order. All right. Okay. All right. So again, folks, hopefully that helps with those three congruence theorems: angle, side, angle, and side, angle, side. All right. So that's that example. More examples coming right up. They coming. The other example is coming. Give me just a moment now. We're going to do it. Come on now. It's coming on along. Don't rush me. Come on now. All right. So here we go. Example 2. Are these two triangles congruent? If so, by what congruence theorem? All right. So folks, again, remember that we have 5 congruence theorems that we've talked about, and those 5 that we have to choose from are side, angle, angle, side, and hypotenuse leg. Those are the 5 ones that we have to choose from, right? So it could be one of these. Yes. Is it one of those? One of those 5? This one, or this one. All right. So it could be one of those 5, guys. Sometimes when you're doing this, you might see some other things that may sort of kind of seem tricky a little bit, but really they're not really all that tricky. So guys, these right here are those congruence theorems that we've discussed. Okay, let me put that in a different color. Hold on. Correct. Okay, if it's one of those 5, then yes, it's correct, folks. Just flow with me real quick, okay? Because for some of these examples that we're going to look at, where we're asking you to prove whether or not these two triangles are congruent, and of course we mean, can you tell that they're congruent by one of these congruence theorems? Guys, for some of these you'll have some other types of things going on, like you may see all 3 angles. Wow, really? You may see all 3 angles from one triangle congruent to all 3 angles in another triangle. Okay, triple A, or you may see two sides and a non-included angle. And folks, if you see these two that I'm writing right here, if you see these two, run! If you see them two, run! Don't you dare try to use those two. They do not work. They are not correct, okay? These two are not congruency theorems, okay? They are not. They do not work. They're not congruency theorems, okay? So if you see those two, if you see three angles from one triangle that are congruent to the corresponding three angles in another triangle, don't try to say that the two triangles are congruent. Please, y'all. Please don't do it. Don't do it. I'm trying to warn you. Don't do it. They are not congruency theorems. Okay, AAA is a type of battery, okay? It's a type of battery, and it's also a type of roadside assistance service, okay? Don't fall for it, okay? AAA is not a way for you to prove that two triangles are congruent. I just try to tell you, alright? It's not a way to prove that two triangles are congruent. Alright, so AAA is not a congruency theorem, okay? Three angles congruent to another three angles, not going to work. Not it, okay? Not it, okay? And then this other one, SSA. Now, y'all, if you know how to spell, if you really know how to spell, if you spell that right there backwards, guess what? I'm not going to say it. You're not going to say it neither, okay? Because we don't use expletives. Expletives, okay? We don't use expletives, okay? I'm sorry about using big words. I'm sorry. I'm an educated man, all right? We don't use expletives, okay? Swear words, what we call it, profanity. You know what I'm talking about. You know, expletives. Those things that get used in sentences that really don't even have to even be there, right? That don't really even make any sense. But anyway, they just prolong. Anyway, we don't use those types of things, you know, and we know what that spells backwards, and when we just don't say that type of thing, we don't say no. It doesn't work. It just doesn't. Okay, I'm trying to give you a warning here. All right, let's move on. Let's go ahead on and talk about this example. All right, I did try to warn you, okay? So don't say I didn't warn you for when we do have examples where you see those two things right here that I'm telling you specifically. I'm telling you that they are not congruency theorems. Okay, I'm trying to warn you that these ones right here are not congruency theorems. Okay. Alrighty. Anyway, let's do this. Alright, so folks, what we have here in this diagram right here. Yeah, right here. What we got right here in this diagram, folks, you can see explicitly and clearly. You can see one angle, one side, right? Okay. Well, that's what you can see. What about what you can't see? What about what you know implicitly, and what you necessarily can't see explicitly? So in other words, they may not actually have certain markings on your diagram, but you should recognize these types of angles right here. You should definitely recognize these types of angles. This one right here and that one. You should recognize what type of angle pair this is. Okay? Don't say we haven't talked about it as much as we have from the first time that we mentioned it. All right, so remember this type of angle pair here, it starts with a V. Right? These are vertical angles, correct? Yes, right? Those angles that get formed when two lines intersect each other, and again, you can see here. Now, just because you don't see like little arrows at the end of those lines, don't mean that. But anyway, all right. So we got these two vertical angles, and we know, folks, that vertical angles the measurements for vertical angles are always equal to each other. That vertical angles are always congruent. In other words, that their measurements are always the same or equal. But vertical angles are always congruent to each other. So they may not have actually had this information marked on your diagram, but again, folks, we got to know what we're supposed to know. If you don't know what you're supposed to know, the stuff that we already talked about in previous lessons that you already supposed to know, you might be a little bit out of luck. Because now again, you can call me. My students enrolled in my class. You can contact me again for help. But again, folks, you supposed to know certain stuff already based on what we've already been discussing and based on what we've already been emphasizing and reiterating in a lot of these videos and lessons afterwards. But anyway, folks, these two vertical angles are congruent to each other, and so they didn't have that marked in your original diagram. But again, folks, if we know that they are congruent to each other, then if we look at these two triangles, okay, yeah, that's just sloppy. Yeah, y'all excuse me. Still sloppy, but it'll work for right now. It's gonna have to. Yep, that's gonna have to do. Sure is, pal. Gonna have to do. If it ain't gonna do it, I don't know what to tell you. I really don't know what to tell you. I'm sorry. It's gonna have to do. Alright, I'm gonna try to make it look a little bit better than that. I don't know how successful I'm gonna be at it, but we're gonna try to make it look a little bit better than that down now. Now, if you know what I'm talking about right here, now. See here, now. If you know what I'm talking about right here, now. See here, now. We're gonna try to make it look a little bit better than what it just did. And maybe it won't look exactly perfect, but close enough, right? So we see those two triangles up there that have the markings that were already there, that were already in there. This angle was congruent to this angle, and this side was congruent to this side. And then, folks, what we just now said was that because these two angles right here are vertical angles, this one and this one, that they have to be congruent to each other, right? Yes. Okay, so this angle and this angle are congruent to each other. So now if you look at these two, at these two triangles, they are congruent to each other. And folks, again, remember I said that again, folks, you can literally follow. You can follow those congruency marks right along your triangle. So if you follow it along one by one, this right here is a congruency mark for what type of part? It's a congruency mark for an angle, right? So there you go, angle. This one, so if we go directly along your triangle, so starting here and then following along your triangle, the next congruency mark that we get to is this one here, right? And that's a congruency mark for what type of part? A side. So there we go. We got angle, side. And now if we keep on going along that triangle, the next congruency mark that we get is right here. And this is a congruency mark for a angle, right? So we have here, if we follow along that triangle, angle, a congruency mark for an angle. Keep going, you get to a congruency mark for a side. Keep going, you get to a congruency mark for an angle, right? And we know that this is an included side for those two angles. So guys, and because we've got this for this triangle, and we've got those same corresponding parts that are congruent in the other triangle, then we can say clearly that these two triangles are congruent by the angle side angle congruency theorem, ASA, right? So these two triangles are congruent. Are these two triangles congruent? Yes, they're congruent. Yes, they are congruent by by the angle side angle congruence theorem. Oops. Yeah, congruent. By the angle side angle theorem. They are definitely congruent to each other. Yes, yes they are. Oops. That is so sloppy, but it's going to have to be all rights. All the rights. Maybe it'll do it right there. Alright, next example. Alright, so here's example 3. Are these two triangles congruent? And if so, by what congruence theorem? Again, folks, remember that we've talked about 5 types of congruence theorems. Again, folks, these two that I have written right here, that triple A and that SSA, again, those two are not congruency theorems. But again, folks, let's go ahead on and do example 3. So again, with this right here, let's look at what we got. Let's look at what we don't got. Right? Notice how for these two triangles, there's a side in the middle for those two. That is technically a shared side. It's technically the same side, and it's a shared side between those two triangles. If you notice that, yeah. If you notice that, that right there. Yeah. Alright, so again, that is the same side, the same shared side for both triangles. So folks, what does that mean? What does that mean for us to have the same shared side in two triangles? Okay, so if these two triangles clearly share that side in the middle, right? And you can see that, yep, this one right here. Yep, it's the exact same side for both triangles. Look at it. You can't be more clear than that right there. All right, so what does that mean? Remember, guys, that we talked about the reflexive property of equality? Yes. Those things that we talked about in the past where, again, one of those 3 properties of equalities or properties of congruence that we talked about, the reflexive property of congruence says that this side is congruent to itself, right? So that means that again, since both triangles share this side and it's technically the same side for both triangles, again, and based on the reflexive property of congruence, if you don't remember that, go take a look at our previous lesson video on polygon congruence. All right, reflexive property, where we said reflexive property of congruence, where we said that any geometric figure is congruent to itself, right? So again, we're going to say here that this side, that this shared side is congruent to itself. And that's what you'd have to actually, what you'd need to know based on looking at that diagram. And that's something that wasn't explicitly marked or explicitly written here on the diagram, but again, it should make sense to you that if you see a side that is shared for 2 triangles, it should make sense that those 2 sides, or technically that one side has to be congruent to itself, right? That's, that should make sense, right? That it has to be the same length as itself, right? I do hope that makes sense. Yeah. If not, okay. Again, if not, my students, you got my contact information. Okay. But anyway, yeah. Contact me. All right. This shared side is congruent to itself. And so since we know that, let me go ahead on and I'm going to redraw that right there. I'm going to redraw that. Okay. Since we know that both of those, or technically that same side for these two triangles is congruent to itself, I'm going to split these two triangles up. Alright, so I'm splitting these two triangles up. You see it. You see it. And again, that side that they both shared, that side that was technically the same for both of these triangles, and again, I split it up so you can see the two triangles separated. Okay, they did kind of sort of look like Siamese twins at first, right? But now they don't look like Siamese twins no more with that same or shared side. Now we've split up the two Siamese twins. Or what they call conjoined twins. Anyway, alright, yep. Alright, so again, that side that was shared is the same. It's congruent to itself. Okay, I'm not going to use that color. I thought I picked a different color anyway. Are we glitching? Are we really glitching right now? When I know I done picked red? Okay, I'm about to say now. Don't be glitching on me. Be glitching on me. Alright. I'm not talking to y'all. I'm talking to this program. Telling it not to glitch on me. Don't be glitching. Nobody got time for no glitches. Don't be glitching on me. Not on me. You can glitch on somebody else that's using it, but not on me. Not today. Alright, so folks, with all that being said, okay, about that same side or that shared side being congruent to itself, now that we've got these three markings here for each triangle, okay, if we follow along in both triangles, literally follow along. Like literally go along the triangle. You see where I'm going? You see how I'm following along the triangle? What's the first type of congruency mark we get to? It's a side. It's a congruency mark for a side, right? Okay, well, awesome. So the first thing that we get to is a side congruency, right? Bam. Let's keep going. Follow along the triangle. Let's keep going. What's the next mark that we get to? What type of marking or congruency marking is this one? It's a congruency mark for a side. And let's keep going. What's the next type of congruency mark that we get to? Okay, this one is a congruency mark for an angle. Well, guess what, y'all? Didn't we say that this one right here, that SSA, that one right there, that one is not one of the congruency theorems that we can use to prove that two triangles are congruent. So guess what? This ain't one of them. This ain't what you want right here. No. It ain't gonna work. It just ain't gonna work. So no, these two are not congruent. Okay? SSA or side-side angle does not work as a congruency theorem. It does not show that two triangles are congruent. So these two are not congruent. It might look like you have enough information to show that they're congruent, but again, this one right here, side-side angle, is not a congruency theorem. Alright, next example. Next example, coming right up. Okay, so here's example 4. Are these two triangles congruent? If so, by what congruence theorem? Alright, so when we look at these two triangles, now guys, those two angles right there are not vertical angles. These two triangles are not connected with vertical angles. They're just two regular looking, well, not regular looking triangles, but they just kind of, yeah, the way they're drawn is a little weird, but again, folks, they're pretty much just two regular looking triangles. Not exactly drawn like that, but y'all know what I mean. Yeah, y'all know what I'm trying to say there. Don't you. Yep, nope. Ain't gonna be able to fix that one now. That's okay. Alright. But y'all see how they look though. These two triangles. Yep, and it still did the same thing. It's okay. It's alright, I'll just use this one. Guys, they do have the same they do have matching congruency marks. But again, if you look at these congruency marks that are up there for this, then you can see like if you follow along the triangle. Okay, the first congruency mark that you get to is for a side, right? So that's S. The next congruency mark that you get to is for an angle, right? If you're following along that triangle, right? So you get to a side, then you get to an angle. Nope, that ain't no angle. Why y'all let me say angle? Y'all know I didn't mean to say angle. I don't know why y'all let me do that. That's okay. That is okay. That is alright right there. That's okay right there. Yuck. Alright. Alright, so that's side, and then of course, guys, the last congruency mark that you get to there is for an angle, right? So if you follow, literally, if you follow along the triangle, doesn't matter which way you go from, or which way you start. Either you're gonna have it in the order of angle, side, or you're gonna have it in the order of side, angle. But one way or another, folks, you can see here that this one here is that one that we said does not work, right? That SSA is not one of them, is not one of the congruence theorems that we use. So these two triangles are not congruent. I say not congruent. I say not congruent. Not. Alright. Next example. Alright, so here we go with example 5. Are these two triangles congruent? If so, by what congruence theorem? So guys, when you look here at these two triangles, they've got matching congruency marks for their parts, but again, you need to check to see whether or not these two whether or not it's actually going to be using one of the congruence theorems that we talked about. So again, folks, the marks that they've got actually got are this one here. Hold on. Wait a minute. There we go. The little 3 thingy there. The little 1 thingy there, and with the little 2 thingies there. Yeah, they did it a little bit different than what I'm doing it, but same concept. They distinguished it. They made it look different. They did like this instead of doing it with 2 things like that. They did it like that. All right, so yeah. Really? It's really gonna act like it's not going to erase that? Okay, good. Alright. Okay, so folks, with this, you can clearly see, like if you follow along the triangle, and even if you don't even have to even follow along the triangle, all 3 of these congruency symbols are for the angles, right? 1, 2, 3. We get an angle, we get an angle, and we get an angle. Okay, all 3 of those are for angles. Angle. Alright, so again, for that, folks, and we know that this is not one of those congruency theorems. It's not one of the congruency theorems. It's not something that we use to actually to prove that 2 triangles are congruent. because it's that, and that's not one of our congruency theorems. These two triangles here are not congruent. Or at least we certainly do not have enough information to be able to say that they are congruent. Let's put it that way. They're not congruent, or at least we don't have enough information to be able to specifically and show enough state to be able to state that they are congruent. We don't have enough information there. So as far as we're concerned, they're not congruent. Alright, next example. Alright, so here we go, folks, with example 6. Alright, so with this one here, again, are these two triangles congruent? If so, by what congruence theorem? Guys, I love it when they take creative liberty like this and draw out your diagram like this. You see how they got these two triangles, but they got them looking so weird and got extra stuff attached to it and everything. But again, folks, if you get confused by how that looks, feel free to separate your triangles out. You can always draw your triangles separate, like what I'm doing right here, right now. Hint, 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 hint. You can always draw your triangles separately. Okay? And you can make sure that you can see everything that you need to see the way that it is, okay? There's a congruency mark there, a congruency mark here, and congruency mark there. There's a congruency mark here, a congruency mark there, and a congruency mark right there. Alright, so we got that, okay? So folks, if we literally follow along our triangle, start someplace and follow along. The first type of marking that we get to is what? For a side, correct? A side congruency. The next type of marking that we get to is for an angle congruency. Angle. And then if we keep on following along that triangle, the next type of congruency mark that we get to is for a side. And it's the same way for both of these, right? Side. Angle. Side. Alright, so again, folks, with this, we got the side angle side. We got the same corresponding parts, and we got two sides and an included angle, that are congruent in both triangles, and those corresponding parts, are congruent. So yeah, definitely, these two triangles are congruent. Most definitely. Oh yes. These are definitely congruent to each other, folks. Yes, they are congruent. They are most certainly congruent. Yes, they are. Oh yes, they are. These are definitely congruent here. They're congruent by the side angle side congruency. Yes, they are. By that theorem. Yes, they are. Oh yes, they are. Oh, they're definitely congruent. No doubt in my mind that they're congruent. I mean, none whatsoever. Okay, well, I thought it was going to do the little thing, but I ain't even worried about it. It's going to have to just look like that for right now. Whatever. It'll be alright. Y'all be alright. Y'all know I'm trying to circle that. It's okay. Next example. Alright, so guys, here, example 7 here, are these two triangles congruent to each other? Oh, I'm sorry. They ask, are these two triangles congruent to each other? And if so, by what congruence theorem? Alright, so, guys, again, if we go ahead on and get together what it is that we've got for these two. We've got, let's see what we got here. We got this congruency mark right there. Hold on, wait a second now. There we go. Alright, that congruency mark, this one, and this one here. and we got this congruency mark, this one, and this one here. Right. So again, folks, if we literally follow along, and guys, you need to do this for both triangles to make sure that those parts are literally matching up and corresponding for both triangles. Okay, so I'm not just doing this for my health. I'm doing this to help you figure out exactly how it is that you need to be doing it too. Okay, you need to do this right here for both triangles. Make sure that you that you know for sure what's going on. If you follow along this triangle here, the first mark that you get to is, okay, this congruency mark is for an angle, right? So that's angle. Okay, what are they doing? Why are they underlining it for? Okay, this one is for an angle. Okay, if you keep going, the next congruency mark that you get to for this triangle is an angle, right? So that's angle so far. If you keep going along this triangle, the next congruency mark that you get to is for a side, right? Okay, awesome, great, lovely, awesome, brilliant. All right, so for that one, we've got angle, side. Let's make sure, you need to make sure that it matches up with the other triangle, because they could make it sort of look alike, but where it doesn't really match up, folks. You need to make sure that you do this with both triangles. I repeat, you need to make sure that you do this with both triangles. All right, just putting a little bit of emphasis, a little bit of umph on that, so you know how important that is, okay? All right, all right now. All right. Okay. Alright, so again, if you follow along in this triangle here, in the first congruency mark that you get to is an angle, right? Angle. You just make sure that it matches up. Like literally matches up every single part of it. The part that has the little two tick marks for the angle matches with that one, right? Angle. No, seriously. Make sure it all really matches up for real. Seriously. Don't just do something just to do something. Okay. Angle, and this one literally matches with that one. Okay, with the one little tick mark for the angle. And then if you keep going along here, the last congruency mark that you get to for this one is a side. Alright, and that one matches up with the other triangle. Alright, so for these two triangles here, folks, we had two angles and a non-included side there. Alright, and so for that, again, we can say that these two triangles here are congruent. Yes. Oh yes. Oh yeah. Oh yes. Oh yes, they are congruent. And they're congruent by the angle side congruence theorem. All right. Yep. Good enough. Gonna have to work for now. For right now, that's gonna have to work. Sideways and all. Alright, next example. Coming up. Alright, so here we go with example 8 here. Alright, so for this one here, with example 8, alright, what we got here, they say, are these two triangles congruent? If so, by what congruence theorem? So again, folks, if we look at both of these triangles, one of them like that, and the other one upside down, or not upside down, but like that. Okay, not exactly like that. Let's see if we can do that a little bit better than that. Yeah, close enough. Alright. Okay, well, these are right triangles. Okay, because we see the little right angle symbols. That doesn't necessarily mean that we'll be able to use the hypotenuse leg. theorem, but they are right triangles nonetheless. Because again, we've got these right angle symbols. All right, what else do they have marked? They've got this side, and they've got this here marked as well. Okay. Right. Okay, so folks, with this, if you follow along here, and there's not much to follow along with here, but if you follow along there, the first congruency mark that you get to is for an angle, right? Yeah. Okay. Even if you don't consider these right angle symbols as congruency marks, folks. Okay. Think of it like this then. If you know that they're right angle symbols, then you know that both of these are 90 degrees, right? Okay, and if they're both the same angle measurement of 90 degrees, then guess what? You do know that they're congruent to each other, okay? So, yeah, alrighty. Just want to make sure that we all on the same page here, okay? If some of you might have been thinking, well, Mr. Starkey, those are right angle symbols, but those are not congruency marks. You're right, they're not congruency marks, but let's use a little bit of common sense there. If we know that they're both 90 degrees, they are definitely congruent to each other. Okay, all right, great. Glad we're all on the same page now. And again, if we follow along that triangle, the first mark that we get to is for an angle congruency, because the right angle there is congruent to the right angle here, right? So that's angle. The next congruency mark that we get to is for a side. Yes. And it even matches up with the other one, side. And then the last congruency mark that we get to is for an angle. Yes, and that matches up. Okay, so it matches up in both triangles with an angle, side, and angle. All right, so we know that based on that these two triangles, yes, these two triangles are congruent. And they're congruent by the angle-side angle congruency theorem. Wow, seriously? Is it really going to do that every single time? Huh, that's annoying. By the angle-side angle congruency theorem for triangles. Haha. Yes, they're congruent. Alright, close enough. Not really. I lied. It's not close enough. Ah, now that's close enough. There we go. Okay, next example. Okay, so folks, here we go. We got example 9 right here. Alright, are these two triangles congruent? And if so, by what congruence theorem? Okay, so folks, we got these two. They're currently they look like Siamese twins, and they're conjoined, and they have one side right there in the middle that's the same, that's shared, and this side, that same shared side, is congruent to itself, right, by the reflexive property of congruence. Yes, it is. Same shared side is definitely congruent to itself by the reflexive property of congruence. That's how we know that it's congruent to itself, or at least that's the theorem that backs up that information, right? That any geometric figure is congruent to itself. Oh, yeah, and I realize how sloppy that handwriting looks, but guess what, folks? Yep, I'm going to say it, and if I say it, then you should be able to read what it says. The same shared side is congruent to itself by the reflexive property of congruence. Awesome. That's what that says. I'm not rewriting it. And that's probably more so, probably bothering me more than what is bothering you, but that's okay. Alright. Anyways, so again, this side right here, that shared side right there in the middle, is congruent to itself. So again, I'm going to split up these two triangles, and I'm going to draw them separately, and we'll do it like that. Yeah, that's just beyond sloppy right there, but okay, whatever. Alright, close enough. And then this one here. Close enough. Alright. Alright, so the marks that we already had up there with this one and that one, and of course this right angle and this right angle, which means that we're dealing with the right triangle. Okay, so it's a possibility that it could be the HL or hypotenuse leg, but again, it does not have to be that one, but it is a possibility that it could be the hypotenuse leg theorem, since we are dealing with the right triangle. So again, this side right here and this side right here were technically the same shared side, and because they were technically the exact same shared side, we know that those two parts, or technically the same part there, is congruent to itself, because it's the exact same part, so it has to be congruent to itself. And so the markings that we have there are for a side, for another side, and for an angle. Okay, well, side angle, that doesn't work, so we can't do it like that. So we'll have to approach this like a right triangle, and we'll have to label the parts that we've got. So one of these congruency parts that we do have here, this part here is a hypotenuse. Yes, you agree? I'm glad you agree. Awesome. Because again, it's the part that is directly across from your right angle, and it's the longest side of that triangle, of this right triangle. Anyway, I'm going to erase that arrow. Alright, so again, there's our hypotenuse, okay? And again, we've got a hypotenuse over there, and those two hypotenuses, or hypotenae, I don't know really what they call that. I think it would be hypotenuses. Hypotenuses. I'm not really sure. You know what? I'm going to have to look that up. See there? I tell you what, boy. Ooh, I'm not sure what the plural would be for that. I think it would be hypotenuses, with just putting the S at the end of it, like use and uses. But anyway, I don't know, I'm going to have to look that up. Not right now, but I will. I'm going to have to look that up, sure enough. Because now I got myself wondering about that. Anyway, these two hypotenuses, hypotenuse, hypotenuse, I'm not sure. Anyway, the plural version of hypotenuse, okay, those two are congruent to each other, all right, and we know that. And the other part that we've got outside of course, the right angle, which we know is definitely congruent to the other one. All right, so but the other part that we've got is this leg, and we've got this leg. And those two legs are congruent to each other, and those two hypotenuses are congruent to each other. So, guess what, guys? You know what? Since we've got a hypotenuse and a leg that are congruent to the corresponding hypotenuse and leg in the yellow triangle, guess what, folks? Then these two triangles are congruent by the HL theorem, the hypotenuse leg theorem. Yes, sir. Yes, ma'am. Yes, sir. Alright. So again, yes. Yes, these are definitely congruent. These are so congruent by the HL theorem. Yes, they are. All right, folks. Now I got a few more examples that I wanted to show you, but you know what, folks? I'm gonna have to. We're gonna have to cut it. We're gonna cut it short. I'm gonna show you one more example to make sure that I've shown you pretty much every type of problem. Not really every single type of problem, but at least covering all of these actual congruence theorems. The side, angle, side, angle, side, and hypotenuse leg. I'm going to show you one more example to make sure that I've covered all 5 of those. And then we're going to call it, okay? Because we've taken up quite a bit of video time and we don't want to take up too much more of that. So I'm going to show you one more example and then we're going to call it quits. Even though I'm not a quitter. I am not a quitter. And I need for you not to be a quitter too. But after this last example, example 10, we're going to call it quits, okay? Alright, last example coming right up. Alright, folks. So here we go. Here we got this here last example 10 here. And for this one, they're saying here, are these 2 triangles congruent? And if so, by what congruence theorem? Alright, so folks, here, you can definitely see here that we got here, yeah, y'all have to excuse the way I'm talking. I'm just tired right now. Yeah, and I might be a little bit hungry too. You know, they got this commercial about Snickers. I just might not be myself right now because of hunger. So I might just need a Snickers at this moment. All right, so here we got this here same shared side here, and of course we know that this same shared side for both of these 2 triangles has to be congruent to itself. We know it's got to be congruent to itself. I mean that just doesn't make sense there. It is congruent to itself, and we know it's congruent to itself by the reflexive property of congruence here. Alright, so it's definitely congruent to itself. Now, that ain't how you spell itself. Good gracious, I don't know what in the world. Okay, wow, what is going on here? You know what? We just going to erase all of that now. There we go. We'll try it this way here. Alright, it is congruent to itself. Alright, and we know that it's congruent to itself based on what the reflexive property of congruence says. Now the reflexive property of congruence, because any geometric figure is definitely congruent to itself. So based on that, folks, based on us knowing that those 2, or technically this same side, is congruent to itself, then what that means is that if we go ahead on and mark out all of this stuff that we know, wow, did it really just switch? It switched colors on me right in the middle of that. This thing is truly glitching. Oh my goodness. I mean, boy, talk about a glitch. Now that's some kind of glitch. If it just switched colors on me right in the middle of writing, it went straight from blue to green. Did y'all see that? A few seconds ago. Goodness gracious. I mean, I didn't even change the color, and it just changed it right on its own. Changed it from blue to green, just like that. Okay, that's close enough, guys. That right there is going to have to be close enough. Alright, so we know again, folks, that side right there, that was in the middle, it was the same shared side for both of these triangles. And so, based on that, we know that it had to be congruent to itself. Let me go ahead on and put the other congruency marks that were already there in these 2 triangles, this one and that one, and then this one here and this one here as well. And then, folks, this side that was shared between both of these right here is congruent to itself. So based on that, folks, we got all three sides here in this triangle that literally are matching and are congruent to those corresponding sides in this other triangle. So based on that, folks, we know that these two triangles have got to be congruent. They are definitely congruent here, and they're congruent by the side congruency theorem. All right, so folks, yes, they are definitely congruent. Most certainly, most definitely, they are congruent. There's not a single doubt in my mind that these two triangles are congruent. And we know that they're congruent by the SSS, the side. The SSS, congruence theorem. And folks, that right there is where we're going to be calling it quits. I do hope that this here video, which is technically was partly a review on what we had already talked about, but folks, again, it wasn't a review in the fact that we talked about or in the fact that we looked at these examples here. All right, so again, folks, I really do hope that this video and that this lesson here has been helpful to you. But again, we're calling it quits right here. We've shown you several different types of examples where we were using these different congruence theorems for proving two triangles congruent. And again, folks, I do hope that it's been helpful. We got to go ahead on and call it, and we're going to go ahead on and end it right here. Well, folks, looks like this is it. We've come to the end of our road. Goodbye. I will see you later. Or maybe I won't. But I will definitely be making more of these videos. Goodbye for now. I hate goodbyes. Goodbye.